Okay. Hello, everyone. This is section 5.3 notes on the binomial distribution. And this is just starting off. I just wanted to start you all off. We will finish the examples in class, but the definitions I wanted to go over with you all. And I just wanted to make sure that we did the definitions together and sort of on the same page in terms of the definitions. So I'm not for sure if I'll continue to sort of do this intro video for each section, and then in class we'll do the examples, or I'll have you do the definitions on your own. Okay, so we'll talk more about that later. But this section is talking about binomial distribution. And so bi means two. So we're looking at things in terms of two outcomes. And so here, if you want, I think it would be best for you to pause the video and write down the definitions first, and then come back and just play the video as I go through these definitions. If you're looking at this online or on your phone, well, you're looking at this online, but I would suggest you write this down in your notebook if that's how you retain information better, by actually writing it down instead of just following through in the video. Okay, so it's up to you. All right, let's get started. So we see here that for number one, we have a binomial experiment and trial. And so experiments that can be classified or condensed to two outcomes are considered binomial experiments. Okay, each repetition of the experience is called a trial. Okay. Conditions. All right, so when we think about the conditions for a binomial experiment, okay, so in looking at these conditions, there are actually four requirements that satisfy a binomial experiment. Okay, so one is that there must be a fixed number of trials. Okay, a fixed number of trials in your experiment. Two, each trial can have only two outcomes. Okay, or outcomes that can be reduced to two outcomes. And these, I don't know why that S is there. These outcomes can be considered as either success or failure. Okay. Three, the outcomes of each trial must be independent of one another, right? And so you may need to go back over your notes and when we talked about what it means to be independent, right? The probability, and the last condition for the probability of success, must remain the same for each trial. All right. So you need to make sure you understand and remember these four requirements for a binomial experiment. And then we have number three, a binomial distribution. And we're going to talk about several distributions coming up. But the binomial distribution is the outcomes of a binomial experiment, and the corresponding probabilities of these outcomes are called a binomial experiment. Okay. And before we move on, I want to make a note on some things. Actually, this 1 through 3 we're done with. This is the other definitions I'm going to make notes on. All right. So number 4, notation. I want to talk about, we can look at notation for binomial distribution. All right. Well, if we have a success, the probability of success, we're going to write as P of S, right? Makes sense. The probability of failure, we're going to write as P of F. Okay. The numerical probability of a success, that's going to be lowercase p. The numerical probability of failure is Q. All right. And we're going to talk about this, but if you know the probability of success, that numerical value, then you just take 1 minus that to get the failure, right? Because it has to sum up to 1. The number of trials we'll call N. And the number of successes in N trials we'll call X. And of course, we're going to do examples on this. Note that X, so the number of successes in N trials, which we're calling X, it's between 0 and N, right? That makes sense. X equals 0, 1, 2, 3, all the way up to N. Okay, so that's notation that we're going to sort of take into consideration moving forward. All right, binomial probability formula. Okay, and so now I want to be a little careful. Now, some of you, I don't know how many of you have heard of this or seen this notation before. N factorial. Okay, hopefully you may have seen it somewhere. If not, that's fine. But it's for whole numbers. So 0, 1, 2, 3, 4, 5, that's what where you would use this. And the formula is n times n minus 1 times 2 times 1. Okay, and so before we move on, so examples of what we call factorials. And so in mathematics, I may have talked about this in this class, but in mathematics, so factorial is an exclamation point. So we use different symbols, and depending upon the context and the type of math class you're in, the same symbol can be used for different things. It's usually clear from the context of the problem what you're talking about, right? So if you're in an English class and you see an exclamation point, of course you know you're talking about grammar, whereas if you're in a math class and you see this, we're talking about factorial. And again, I'll just rewrite. N factorial is n times n minus 1 times, we can actually put n minus 2 all the way down to times 2 times 1. So for example, if I asked you to figure out 5 factorial, then you would say 5 times 4 times 3 times 2 times 1. All right. So you always go down times 2 times 1 and figure that out. Right. So 10 factorial would be 10 times 9 times 8 all the way down to times 2 times 1. All right. So of course you definitely will need your calculators as always. And in mathematics, mathematicians of many, many years ago, they get together and make up what's called a convention. And a convention is, this is what in the mathematical world, this is what everyone agrees on. So for instance, the order of operations, please excuse my dear Aunt Sally, you may remember that from school. That's a convention, right? And that helps you to know what order to use if you have multiple operations. And so here, in terms of factorial, it's been made that 0 factorial is going to be 1 and 1 factorial will be 1. Okay, so that's conventions that we know. And so that's factorials. All right, so let's go back. Okay, so now looking at number 5, we're on number 5. In a binomial experiment, the probability of exactly x successes and n trials is the following. P of x equals n factorial all over n minus x factorial times x factorial times, so that's all in the denominator, times p to the x times q to the n, let me erase this, to the n minus x. Okay, and again, we're going to do examples to use that, but that's the formula that this is called the binomial probability formula. All right, so again, it's in the numerator, you have n factorial. Really in the numerator, you have all of this, right? Because this is sort of in the numerator as well. If you want to think of this as all of this being over 1, right? You multiply straight across. So if you want to look at it that way, of course you can. So n factorial in the denominator. So you only have, and let me use a different color. And this is the only thing in your denominator. All right, so everything in yellow is in your numerator. So if you want to put that all in one fraction, the book separates it. I'm not for sure why, maybe just to clearly distinguish it. But this is how this is the binomial probability formula, and we'll be using this in this section. All right, and then number 6, mean, variance, and standard deviations for the binomial distribution. Okay, so here the mean actually should look familiar to you because we use our mu. Oh, that mu looks not like a mu. All right, mu, the Greek letter mu, equals n times p. So remembering from the last section, this is actually our expected value formula, right? Our expected value that we talked about already. Variance, when we talk about a binomial distribution, is given by sigma squared n times p times q. And then you all should already know, if you know the variance, then you definitely should know what the standard deviation is, right? Because you just take the square root of the variance. And so sigma is going to be the square root of n times p times q. I'm going to stop this video here, but I am doing a second video going over examples 1 and 2 from the notes. And then we'll be done and we'll finish in class.